Hello everyone, welcome back. I'm Vijay and today we are going to dive into intricate world of Arduino Pinout. Understanding these pins is crucial for unleashing the full potential of your projects. Let's get started. Let's break down this pinout to see what each pin does. These are marked. These are marked on Arduino as you can see, but for explanation, it is better to use the pinout diagram. So this is the pinout diagram I have taken from the Arduino website. You can match these with your hardware. So first up, we have the digital pins. These pins can be used for both input and output. There are total of 14 pins labeled from 0 to 13. They can be configured as input to read digital signal or output to send digital signals. Digital pins 0 and 1 are also known as RS and TX, which stand for receive and transmit and use for serial communication. Moving on to analog pins, the Arduino UNO has 6 analog input pins labeled A0 through A5. These pins can read analog signals, which is incredibly useful for interfacing the sensors with other analog devices. Next, we have PWM pins. Pulse width modulation allows you to simulate analog output by varying the duty cycle of the digital pin. We'll see in detail about PWM as well in later videos. Pins 3, 5, 6, 9, 10 and 11 are capable of PWM output. Now let us look at the power pins. We have ground pin which provide the reference voltage for your circuit. Then there is 5-volt pin which supplies a regulated 5-volt power and 3.3-volt pin for low power applications. Additionally, there is a V-in pin which allows you to supply an external voltage to power the board. Next, there is a reset pin. This pin allows you to reset the microcontroller, restarting your program. Beyond these basic pins, there are few more pins that we need to talk about. Let us break it down to see what each one does. First up, we have reference pin. This is the reference voltage pin by default. It's connected to the internal 5-volt reference, but we can use it to provide an external reference voltage if needed. It allows for more precise analog to digital conversion when working with sensors. Now we can move on to I2C pin. The Arduino has dedicated pin for I2C communication. These are A4 and A5. Again, I2C communication protocols we'll be taking up later in a separate video. So I2C is a powerful communication protocol that allows multiple devices to communicate with each other using just 2 wires, that is SDA and SCL. These pins are essential if you are working with I2C enabled sensors such as IMU, pressure sensor and many more. Moving on, we have SPI pins, that is serial peripheral interface. These pins are used for high-speed communication between Arduino and external devices like display, SD cards, and sensors. The SPI pin on the Arduino UNO are 10, 11, 12, and 13 pins. Each of these pins opens up a world of possibilities for your projects. In upcoming videos, we'll explore how to use these pins to build exciting projects. So, if you found this video helpful, don't forget to like this video and subscribe for more tutorials.